What is Kessler Syndrome? A closer look at space debris and its consequences. Kessler Syndrome is one of the most significant threats to the future of space exploration. With satellites becoming an integral part of our daily lives, the rising issue of space debris could disrupt communications, weather forecasts, and even space missions. In this video, we'll break down what Kessler Syndrome is, how it works, why it's such a serious concern, and how it could impact the future of space exploration. Understanding Kessler Syndrome, the chain reaction of space debris. Kessler Syndrome, also known as the Kessler effect, is a theoretical scenario where the density of objects in low Earth orbit, LEO, becomes so high that collisions between objects create a cascade effect. Each collision produces more debris, which can then lead to even more collisions. This cycle continues to grow exponentially until the near-Earth space environment is filled with debris, rendering space operations unsafe or impossible. The term was first proposed in 1978 by NASA scientist Donald J. Kessler, who warned that the growing amount of space debris could one day result in a catastrophic chain reaction. As more satellites, rockets, and spacecraft are launched into space, the risk of creating debris increases. But how bad could it get? Do you think space debris is a major issue right now, or is it still something that can be managed? Drop your thoughts in the comments below. Why is Kessler Syndrome becoming a bigger problem? As the number of satellites and other space objects increases, the risk of Kessler Syndrome grows. Many companies, such as SpaceX, are launching massive satellite constellations to provide global internet coverage. While these technologies hold promise, they also add to the space debris problem. The more satellites launched, the higher the chances of collisions, which means more debris. This is especially concerning as some space objects, once destroyed, can stay in orbit for decades, complicating the problem even further. In 2007, China conducted an anti-satellite missile test, destroying one of its own satellites. This act created thousands of pieces of debris, many of which remain in space. The incident brought the issue of space debris to the forefront, highlighting how a single event could significantly impact space operations. Other nations like the US and India have followed suit, further increasing the number of debris fragments in orbit. Should nations be more responsible about testing anti-satellite weapons, or is it inevitable? What do you think? The potential impact on modern society. The consequences of Kessler Syndrome could be catastrophic to modern society. From GPS and telecommunications to weather forecasting and military operations, our world depends heavily on satellites. A large-scale space debris disaster could lead to the collapse of satellite-dependent infrastructure, causing widespread disruption in communications, transportation, and military systems. Imagine if every satellite in orbit was destroyed. How would the global economy be affected? How could industries that rely on satellite data, like agriculture, telecommunications, and banking, survive? How would your daily life change if suddenly all satellites stopped working? Would society be able to adapt quickly enough? The dangers of space debris. Moving fast and unpredictable, space debris travels at incredibly high speeds. A single piece of debris, even if small, can cause significant damage to satellites, spacecraft, or the International Space Station, ISS. The high velocity at which debris moves, 18,000 miles per hour, about 29,000 kilometers per hour, means that any collision with an object in space could result in catastrophic damage. In fact, the damage from a small piece of debris can be similar to being hit by a bullet. That's how fast these objects are moving. As the debris field grows, the likelihood of a catastrophic event increases. But what would happen if a satellite were to be hit by space debris at those speeds? Do you think there should be more investment in space debris cleanup, or is it something that will naturally solve itself? The space race for debris solutions. As the space debris problem grows, scientists and space agencies are scrambling to find solutions. NASA and other space organizations are exploring methods for removing debris from space, such as using robotic spacecraft to capture and deorbit space junk. Additionally, some companies are working on developing technologies to prevent space debris from being created in the first place, such as designing satellites that can be safely deorbited at the end of their operational life. But is this enough? Can these technologies prevent Kessler Syndrome from becoming a reality? Or is it already too late? What's your take on the potential solutions for space debris? Do you think they're enough to address the problem, or should we be doing more? What about space traffic control? As space becomes more congested with satellites, some experts have suggested that we may need a system of space traffic control to manage the increasing number of objects in orbit. Just as we have air traffic control to prevent collisions between aircraft, space may need a similar system to keep satellites and debris from crashing into each other. But how realistic is this? Would it be possible to monitor all objects in orbit and prevent accidents before they happen? Would such a system require international cooperation? Should we implement space traffic control now to prevent future accidents? Or is it too early to think about that? Closing thoughts. How close are we to a space disaster? While Kessler Syndrome hasn't yet reached a crisis point, it's becoming increasingly clear that the risk is growing. With the continuing increase in the number of satellites launched and the growing amount of space debris, it's essential that we address the issue before it's too late. The damage caused by a large debris field could be disastrous for modern civilization, as many aspects of our lives depend on satellite technology. The question now is, how much longer can we ignore the threat of Kessler Syndrome before it becomes an irreversible disaster? What do you think? Are we doing enough to prevent Kessler Syndrome? Or is space debris going to become a crisis sooner than we think? Share your thoughts in the comments.